Hello, this is Dr. Mode, and this is going to be a BCA method stoichiometry practice problem. This question is separated into two parts. The first part involves us balancing the chemical equation. The question says, Cindy Lou Who reacted calcium nitrate with iron 3 phosphate to produce calcium phosphate and iron 3 nitrate. Balance the chemical equation. So what we have to do is figure out what these formulas are. The first one is calcium nitrate. Calcium's in the second column on the periodic table. It's always going to have a +2 charge, and nitrate has a -1 charge. So what we do is drop and swap those charges, and we end up with 1 calcium and 2 nitrates. The second reactant is iron 3 phosphate. So that 3 in parentheses means that the iron has a +3 charge. The phosphate has a -3 charge. So if we drop and swap those, they reduce, the 3 and 3 reduce like a fraction, so we end up with just 1 iron and 1 phosphate. The first product is calcium phosphate. Calcium again has a +2 charge, phosphate has a -3 charge, so if we drop and swap those, we end up with 3 calciums and 2 phosphates in this formula. The last reactant is iron 3 nitrate. Again, iron has a +3 charge, nitrate has a -1 charge, so when we drop and swap, we end up with 3 nitrates for every 1 iron. So we can put this into a chemical formula or a chemical equation, and we can see that it still needs to be balanced. The number of atoms on both sides is not the same. First, let's look at the calciums. Calcium has, there's 1 calcium atom on the reactant side and 3 on the product side. So we could put a 3 in front of the first reactant to correct that. And then if you look at the second reactant, it has a phosphate in it. So there's 1 phosphate on the reactant side and 2 on the product side. So we could put a 2 in front of that iron phosphate on the reactant side. And then on the product side, we need, let's see, we need the number of irons to balance. So we can see that we have a 2 on the reactant side, so we need a 2 on the product side in front of the irons. So our coefficients in the balanced chemical equation end up being 3, 2, 1, and 2. Again, we don't write the 1. So the second part to this question is to do a stoichiometry problem. So it says, if she reacted 800 grams of calcium nitrate with 515 grams of iron 3 phosphate, how much of each product in grams was produced? What is the limiting reagent and what is in excess? How much excess reactant is there? And it says to use the BCA method. So we have our balanced chemical equation. So let's extract the information that we need from the problem. Well, first of all, we're given the 800 grams of calcium nitrate. So let's write that under the calcium nitrate. And the 515 grams of the iron 3 phosphate. The next thing that we need is how much of each product was produced. So I put a question mark in grams under each product because that's something that we need. We also need the molar masses of each reactant and product. So all 4 of these are going to have to be calculated. So now we can start our stoichiometry problem using the BCA method. So we need to set up the BCA table. It looks like this. Again, the BCA table is a mole table. Every number in this table will be in moles. So the first thing that we need to do is indicate how many moles of each product there are before the reaction starts. This is the easy one. Both of those numbers should be 0. No product at the beginning of a reaction. Then we need to write down the number of moles of the 2 reactants. So we see we have 800 grams of the calcium nitrate. So if we take the 800 grams and we divide by its molar mass, 164.1, we end up with 4.875 moles of calcium nitrate. We need to do this with the other reactant, so we have 515 grams, and if we divide by its molar mass, the 150.8, we end up with 3.415 moles. The next step is to figure out which of the reactants is our limiting reactant and which one is in excess. So these numbers are kind of close. It's not obvious to me which one is the right answer to choose. So I'm just going to choose one. So let's choose this one right here. Let's choose the iron phosphate and see how it works out. So if I choose this, what I need to do is figure out how much of the calcium nitrate is needed to fully react with the 3.415 moles of iron phosphate. So to do this, I multiply by the mole ratio. This 3 and 2 that I'm multiplying by, 3 over 2, comes from the coefficients up in the balanced chemical equation that I have highlighted in yellow. Okay, so when I do this multiplication, I end up with 5.123 moles. So that means that to fully react with the 3.415 moles of iron phosphate, it requires more than I actually have. Okay, so this tells me what I need to know. This tells me that I chose wrong, okay? I chose wrong because I don't have enough of the calcium nitrate. So this tells me that my calcium nitrate was in fact my limiting reagent. So now that I've identified my limiting reactant, I need to use that number to fill out the rest of the BCA table. So I'm going to use the 4.875 moles of calcium nitrate to figure out how much of every reactant and product was consumed or produced in this reaction. So first thing I'm going to do is I am going to take that number, 4.875, and I'm going to multiply by 2 over 3. This 2 over 3 comes from the balanced chemical equation up top. So the iron 3 nitrate product has a coefficient of 2 in front of it, and the calcium nitrate reactant has a coefficient of 3 in front of it. So I need to multiply by the 2 over 3 to figure out that there's 3.25 moles of the iron 3 nitrate product produced. I'm going to do the same thing with the calcium phosphate. The coefficient in front of calcium phosphate is a 1. So it's in a 1 to 3 ratio. So I'm going to multiply by 1 over 3. And I'm going to get that 1.625 moles of calcium phosphate is produced in this reaction. Then I'm going to do this for the other reactant. How much of the other reactant is necessary? Well, in the balanced chemical equation, these are in a 2 to 3 ratio. So I'm going to multiply by 2 over 3 to get that I'm going to consume, now there's a negative sign in front of this, I'm going to consume 3.25 moles of the iron phosphate. You can see that I'm not consuming all of it because this iron phosphate was the one that we determined is going to be in excess. And then finally, I'm going to consume all of my calcium nitrate, and that's going to leave me with 0 moles of calcium nitrate left over. So I do the arithmetic on all of these right here, and I can see that how much I have at the end of the reaction after the reaction is over with. So in our question, it said to identify the limiting reagent and what's in excess. So this is the question we need to answer here. We already know it, we just need to indicate it. So because we have 0 moles left over of the calcium nitrate, that is our limiting reagent. And because we have a positive number of moles left over of the iron 3 phosphate, that means that reactant is in excess. So another question that we need to answer is how much excess reactant was there? So we look at the number I've now highlighted in green. It says that we have 0.165 moles of iron 3 phosphate left over after the reaction is over with. So what we need to do is just convert that into grams, and we do that by multiplying by its molar mass to find that we have 24.9 grams of iron 3 phosphate left over or in excess after the reaction is over with. Our final question that we need to answer is how much of each product in grams was produced. So I've highlighted the two products in orange and green here. And what we need to do is just convert both of those to grams. So the 1.625 moles of calcium phosphate, we need to multiply by its molar mass to find that we will produce 504.1 grams of calcium phosphate. And then the final reactant, we have 3.25 moles. We multiply by its molar mass to find that we produce 786.2 grams of iron 3 nitrate in this reaction. Thanks for watching.